Hello. This is going to be a discussion of the Bayesian approach to statistics as well as Bayes' theorem. So this goes a little bit away from the Python programming to sort of a little more of a philosophical discussion, and then getting into some of the how Bayes approaches the math aspect of the statistical thinking. It's a much more probabilistic approach. So, at least for me, it took a while to think in Bayesian as opposed to the more conventional statistical ways. I'm going to try to discuss it using this notepad. It's like a digital notepad. I would use a whiteboard for this discussion, but since I don't have one, and if it was a face-to-face situation. But the other thing that I wanted to bring up, one of the most famous current applicants or users of the Bayesian approach. I'm sure most of you are aware of Nate Silver with 538. He started off with political forecasting. Well, he did, I think, even before politics, he did baseball. Now it involves many different sports. You can see politics, sports, economics, culture. So he applies the Bayesian approach to thinking in various different ways. We'll probably look at some of the examples sometime later. Coming back to this, let me try to discuss the distinction between the Bayesian approach versus the more, what would be considered the more conventional approach. So let me use this pad. You can tell me whether this is working or not, and maybe I'll try some other means later on. So the Bayesian approach goes back, ironically, much before. So I'll contrast the Bayesian approach with what's referred to as the frequentist, sometimes called the Fisherian approach. Okay. This is the more conventional statistical approach. The Bayesian approach tends to be focusing on probabilistic thinking, and it also it doesn't when we say think in terms of probabilistic assigning probabilities, it's not saying that the world is or nature is. So it's not that the world or nature is intrinsically uncertain. Intrinsically uncertain. Instead, the Bayesian approach is stating that human understanding is limited in terms of understanding the world or nature. That the uncertainty is regarding the human ability to understand. So as humans, we don't quite fully understand world or nature. So our understanding comes through approximations. So it's a gradual getting closer. So we are getting closer and closer to truth. Okay. So this was this is sort of the basic philosophy behind the Bayesian approach, and this goes back to the 1700s. Thomas Bayes was sort of the originator, and he lived from 1702 to 1761. So it's named after him, though most of the work was done by a French, I believe he was an astronomer. He was using this approach to calculate distances of planets. Laplace, who lived 1749 to 1827. So while the frequentist of Fisherian approach, the one that the statistical approach that we are more used to, its main proponent was Ronald Fisher, who who did most of his work in the 20th century. So ironically, the Bayesian approach predates the frequentist or Fisherian approach by a significant margin, but the Fisherian approach basically says that the uncertainty, the human element is sort of removed. So the uncertainty in the Fisherian approach, uncertainty is due to sampling errors, or solely due to sampling errors. So the philosophy here is the greater the amount of data that you have, the closer you get to the whole population, the less. So it implies that the errors approach zero as you keep collecting or getting more data. The Bayesian approach, on the other hand, is, well, you have a prior understanding. So you have a prior understanding of an event or some phenomena, and you always express it in terms of some probability. Then you collect some data, and then you end up with a posterior understanding, which is also stated in some probabilistic term. So this is broadly the distinction between the Bayesian approach and the frequentist of Fisherian approach. It's a very probabilistic approach, and so I wanted to sort of make that initial introduction. The next video I'll record the actual math behind it, and then follow it up with some examples.